Hello, in this video I'm going to be showing how the quotient rule and the product rule, they basically contain the same information, and from one can derive the other. So say we didn't know how to use the quotient rule. So we could get the quotient rule and we could put it in this form. Put this form into this form by just putting an inverse on it. And we'll say this is a function of x. This is a function of x as well. And we know how to use the product rule. So let's assume we know how to use it. And using the product rule from here, we can see that we get this, and for the second term we get this f of x times, and then we use differentiation. So we get this minus here, this minus 2, and we use the chain rule and we take a derivative here. So, and we're being a little bit more explicit here. We're showing our functions as a function of x. We're taking derivatives with respect to the x. We're not using the prime notation. We want to be a little bit more explicit. We can see what's going on here. And right here, we just move this minus sign, which means it's on the wrong side of the. It means that it doesn't belong in the numerator, it belongs in the denominator. So we put it here in the denominator here. And right here, we just pull out this minus sign. And again, here we have this minus 2, which means it belongs in the denominator squared. And we see here that we want to simplify this a little bit to get a common denominator. So we're going to multiply here by g of x and up here by g of x. And then we get a common denominator, and then in the numerator we can just put our terms here. So right here we've got our g of x times this derivative of f with respect to x. We've got our f of x here and our g of x here. And this is the standard product rule. And if you're not comfortable seeing this derivative notation, we can use our prime notation. And this is the standard way to take a derivative of a quotient. And from the product rule, right here, we were able to derive the quotient rule. And the same goes for the quotient rule. If we didn't know how to take a derivative of using the product rule, say we only had the quotient rule, we can get this form, which we would normally use the product rule, just by putting an inverse on this g of x, which means that it doesn't belong in the denominator. We could use the product rule. So to use the product rule, we would have to square this, which would be g minus 2 squared, minus 2 in the function of g of x, and we would just, in the numerator, we would have our g inverse of x times our derivative of f of x minus f of x times our derivative right here, derivative of this g inverse function. And just going through here and simplifying some of the stuff, we get this g inverse of x times the derivative of x minus f of x. And right here we're going to take a derivative and we're going to use a chain rule. So we get a minus sign here, and this becomes minus 2. And with the chain rule, we take a derivative of this function of x. This is all over g of minus 2. And this minus 2 means it's on the wrong side of the, means it does belong in the denominator, it means it belongs in the numerator. So, and it's going to multiply everything up here once we bring it up to the numerator. So we get this g squared function times all this numerator, and it simplifies it quite a bit. So the law of exponents, this g squared times this g minus 1 of x function is going to give us just the g of x, and this is going to multiply this derivative of f of x. plus our f of x, and this g squared and this minus 2 exponent on this g are going to cancel out, so that's going to be nice. And we're left with just this f of x times this derivative of g of x. And this is our standard product rule. And if you're more comfortable seeing it in the prime notation, we get this g times f prime plus f times g prime, which is our product rule. And of course, this prime indicates derivative, to take a derivative with the, it's understood here that our functions are of x, so take a derivative with respect to x. And we were able to show that these two ways of taking derivatives, they both have the same information. You could just massage your function you're trying to take a derivative of into either form, and you get the same results. Some are easier to use than others, so this is a good exercise in calculus to see if you're using the product rule right, or the quotient rule right, and the product rule right. It's good to brush up on your calc.